Hi, I'm Will Percival. I am a Professor of Astrophysics at the University of Waterloo, where I hold the Myconophilia lazaridis Distinguished Research Chair in Astrophysics, and I'm also Associate Faculty at the Perimeter Institute. Where were you on 9th of November 1989 when the Berlin Wall fell? Well, on 9th of November 1989, I was a high school student back in Coventry in the United Kingdom, and I was just starting my journey in science. I just started to understand the fundamentals of mathematics and physics. What did you want to become as a child? Did this wish come true? So as a child, when I was at school, I just wanted to be a mathematician. I loved numbers, I loved theorems and proofs, I loved the logic and the sense of completeness behind mathematics. I guess you could say it's come true. I'm an applied mathematician. Which wall does your research break? My research breaks the wall of understanding the universe. I am an observational cosmologist. I want to understand the universe as a whole. And to do that, I helped put together what are called galaxy surveys. By observing the three-dimensional positions of millions of galaxies, we can really tell things about the universe that we couldn't tell otherwise. The universe is an incredible laboratory for us. We can do experiments that we cannot do on Earth, that we cannot do in the lab, and that we can test physics at its most fundamental level. What is the challenge that your project addresses, and what is its solution? There are big problems at the moment at the heart of cosmology, in particular in terms of the energy density of the universe. We only understand really well about 5% of that. Only 5% of it is made of what we call baryonic material. That's material that interacts through gravity and interacts through light, like this desk is doing. 25% is in the form of dark matter. This interacts through gravity, as with ordinary matter, but it doesn't interact with light. And 70% of the energy density is in the form of dark energy. This is a very mysterious component. It has incredibly weird properties. In particular, it has an equation of state that's negative. So if you squeezed a ball of it and you applied a pressure, its density, rather going up, would go down, which is just counterintuitive. But we think that most of the energy density in the universe is in this form, and this gives rise to the acceleration of the universe that we see at present day. What is the essential new finding of your research? The galaxy surveys that I helped put together are right at the cutting edge of science. We observe larger volumes of the universe, we observe more galaxies than have ever been seen before, and by doing that we can make better and better measurements of some of the fundamental parameters of the universe. How does or will society benefit from your research? One can argue that it's one of the most basic human endeavors is to try to understand things and understand the universe, why we're here and why the universe has the properties that it does. And for example, when we announced the results from the EBOS survey earlier this year, there was incredible public interest in it. People were really excited to see the maps and to know about the science that we could do from them. Which questions remain unanswered? We have dark energy. We have 70% of the energy density in the universe, which we just don't know what it is. We've given it a name, we call it dark energy, but naming something doesn't lead to the understanding of it. And dark energy is a big mystery. People have tried to put together theories for what it might be. In general, those theories, they don't really work. Which part of your research keeps you lying awake at night? So I must confess here that I am a perfectionist, and the part that keeps me awake is trying to do things perfectly. In particular, once we've got this galaxy survey data, it represents an incredible resource. It also represents a lot of money that's been spent by governments around the world to do this research, and we want to analyze it in the best way possible. What does your child think about your work? My children, I asked them in answer to this question what they thought I did, and they said that I spend all day on my laptop writing emails, which is factually correct, but it's what those emails are about that's interesting.